All right, here we are on chapter 4 on fractions, and this is section 4.2, multiplying fractions. So the multiplication rule for multiplying fractions is to find the product of two fractions, one a over b, the other c over d. And basically, we just multiply numerators and denominators. And so if we write it side by side, a over b times c over d, we're just going to take a times c over b times d. And so that's how we're going to do multiplication of two fractions. Now, this is one of the things that we're assuming that we don't have to reduce anything. So this is the first one where we have basic numbers and we don't have to reduce at the end, because whenever we get done with a multiplication or a division or adding or subtracting fractions, we always have to reduce it to the lowest terms. And so with these, we're not going to have to do any reducing because they're set up in a way that we just can multiply and we're done. All right, so looking at that, here we have 1/4 times 3/5. So again, we're just going to take the a times c, which is 1 times 3, and that's going to be 1 times 3 over 4 times 5, and that gives us 3 over 20. Now, once you get good at this, you can just start saying, okay, 1 times 3 is 3, 4 times 5 is 20, and you can skip this middle step as far as how it's written now. Eventually, when we start having to reduce, sometimes we reduce when we have the original problem, sometimes we rewrite the problem to do different things, and so we're going to be adding and changing steps as we go along here. So all right, so the next one, we're going to have a negative 3 times a 2 over a 5 times a 7. Again, multiplying across the numerator and the denominator. So negative 3 times 2 is negative 6. 5 times 7 is 35. And that is our final fraction in the reduced form because we can't reduce anything. Now, here we have 6 times 4 and 7 times 5. So 6 times 4, that's going to give us 24. 7 times 5 is, again, 35. Okay? So that would be our final form of that one as well. Okay, moving on to the next one. Now, this is when we have problems that are a little more complex, and we have to actually do some cancellation. So one can cancel before we multiply to simplify the problem, or they may reduce it afterwards. Now, it's easier before, just so you know. And so we must cancel a factor in the numerator for the identical factor in the denominator, which we've seen before when we reduce fractions. And what happens is, when we rewrote these, we had numerator and denominator, and we could cancel top and bottom. That was not a problem. And so that's kind of what we're going to do here. We're going to have all the multiplications in the numerator, all the ones in the denominator, then we cancel wherever they are. Now, factors are best as prime numbers. So what you might want to do is factor your numerators and denominators to prime numbers and then cancel before you do any of that multiplying. And that's kind of the key thing, is we might have an extra step where we write out our factors on the numerator, factors in the denominator, and then show the cancellation, and then we can do our final product in the numerator and denominator. Now, one thing to note is, and this is where some people get caught up, if we cancel everything in the numerator and the denominator, that's going to give us an answer of 1, not 0. A lot of people think if you've canceled everything in top and bottom, that must mean it's 0, but that's not correct. It's actually going to be 1, because this divided by this is 1, this divided by this is 1, this divided by this is 1, and so we have 1 times 1 times 1, which is 1, and so it really is equal to that 1. All right, so again, what we're going to do is we're going to start and do it in one way, and then we're going to gradually assume that we're getting better at it and we don't have to do it that way anymore. And so what we're going to say is we're going to take 3, because that's a prime number, times, well, 25, well, that's 5 times 5. So we've broken that down into the primes. Then we have 5 here, and 6 is going to be 2 times 3. Okay. Now what we can do is we can change our color so we know what we've done. Cancel that 5 with that 5, that 3 with that 3, and now we have something we can multiply. Well, we just have 5 over 2. Okay. Now, one thing is, while we're on the simple one, let's go ahead and show you here. What we could do, instead of writing it out like this and factors like that, we could say, okay, well, in the numerator and denominator, what we're going to see is this is all going to be a product. So, oops. So really, what we can do is say, well, that's that times that. And now we can say, well, can we cancel anything? Well, 5 goes into 5 one time. 5 goes into 25 5 times. And here 3 goes into 3 one time. 3 goes into 6 two times. Now we have 1 times 5 is 5, 1 times 2 is 2, and we still get our same answer. And again, all we did was we just changed it to multiply here, and then we reduced by basically dividing into the other one. All right, so let's do it again like the first way, and then we can come back and check out the other way. So we're going to have a negative 3x times, and then 6 is 2 times 3 all over. Here we have 2 times. Now 21 is 3 times 7, and then we have times x times x times x. Okay, and again, we're doing this to kind of get us used to doing the shorter way, but we have to figure out why we can go over here and just start canceling things like we did here. All right, so now what do we have? Well, we're going to still keep that negative, so now we can cancel that 2 with that 2, that 3 with that 3, that x with that x. And now let's go ahead and circle what we have left. We have the negative 3, we have a 7, and we have 2 x's. Okay. So writing that, we have negative 3 over 7x squared. Okay. Now, can we get that doing it the way up here? Well, 2 will go in here once, 2 will go in here 3 times. Now we can say, well, this negative 3, we're just going to say divide it by 3, and that's going to give us a negative 1 still. Divide that by a 3, and we have 7. Well, one of these x's will cancel one of these and leave us with 2. So we're taking one of those and getting rid of it, and taking one of those and getting rid of it. So it takes it down to 2. And so now we have a negative 1 times 3, negative 3. 1 times 7 is 7 times x squared, 7x squared. Okay, so that's kind of the two ways we can do it. Some people are going to like this way because it's just quicker. You just start canceling things. Other people are going to like to work it out this way and, really pay attention to how things are canceling out, and so they can follow along a little easier. All right, so let's go to the next one. Well, 21, well, here we go. Well, that's 3 times 7. And then 45, well, that's 9. Well, but 9 is not a prime number, so we can't just say 9. We better say 3 times 3 times 5. So that's 9 times 5 is 45. All over. Now we have 30, so that's going to be 2 times 15, and 15 is 3 times 5, so that's going to be 6 times 5 or 30. And times 14, which is 2 times 7. Okay, so that's 30, 14, 21, and 45. All right, so that looks good. So now cancel. Well, that 7 will cancel that 7. That 5 will cancel that 5. Then we have 3's, and here's a 3 we can get rid of. 1, 3, and 1, 3. All right, so now let's go back over here and say, what does that equal? Well, we should probably circle what we have left over. So we have a 3, a 3, a 2, and a 2. So now we have 3 times 3, which is 9, and 2 times 2, which is 4. Now, can we reduce it over here instead? Yeah, sure we could. Well, what do we have? Okay, 7 will go into 21 and to 14. So 7 goes into 14 twice. 7 goes into 21 3 times. Now, what do we have? Well, now we can say, well, 3 here will go into once. 3 will go into here 10 times. Now, both of these have a 5 in common. A 5 goes into here 9 times. 5 goes in here twice. And so now we have 1 times 9, which is 9, and 2 times 2, which is 4. So this time we did it, but we had to do a couple steps, some of them. We had to reduce it twice, and here twice, those two just once. Okay, so again, you can do this way, or you can spread it out and do it the long way like this. All right, what about this one? Well, that gives us 7 times x times x. And again, we're going to split it out into all the primes over here. Then over here, we're just going to cancel. And then times, well, 30, well, we found that was 2 times 3 times 5. Then we have times y times y times y all over. Now 60, well, that's going to be 30 times 2. So it's going to be 2 times 2 times 3 times 5 times y times y times y times y, because we have y to the fourth. And then 49 is 7 times 7. And then we have times x times x times x. Okay. All right, so now let's start canceling. What do we have? Well, one of these 7s will cancel one of those. One of these 2s will cancel that. 3 will cancel 3. 5 will cancel 5. Now we can start working with x's. So one of those x's, one of those x's, another x, another x, that y, that y, that y, that y, that y, and that y. And now I think we've canceled everything. So now let's circle what we have. On the top, we don't have anything. So remember, when you cancel everything, that's just equal to a 1. So we have a 1 up here. And then down here, we have a 2, we have a y, we have a 7, we have an x. Okay, so let's write that out. So we have 1 over 2 times 7, which is 14. And then we have y times x, or xy if we put it in alphabetical order. And that seems to be our answer. Now let's test it and see if when we cancel things over here, we can get the same kind of thing. Well, this 7 will cancel and it goes in once, and it'll go in here 7 times. Now that 30 will go in here once, and it'll go in here 2 times. Now, if we take off 2 of these, from here, we're left with 1. If we take off 3 of these out of here, we're left with 1. And so what we have is 1 times 1, which is 1, so it looks good. Here we have 2 times 7 is 14 times y times x, or x times y. And so that's what we have here. So that looks good. And again, you can do it by splitting it apart into primes, or you can go ahead and go down and just start canceling things top and bottom. That will cancel out. Sometimes you have to do multiple times when you do it that way, but it works. Whereas here, it would all be spread out and you just cancel and then you're done and have to multiply back through. All right, what about here? All right, let's get our purple back so we can have consistency. So this is going to be 7 times a times. Now this is going to be negative, so we can take that negative out front. So let's put a negative out here because we know that negative when we multiply is going to be there. And 36, well, that's 6 times 6. That's going to be 2 times 2 times 3 times 3. That's 6 times 6 times b times b. And then 18, that's 2 times 9, so 2 times 3 times 3 times b times 2 times 7 times a, because 14 is 2 times 7. So I think we have everything cancel or spread out. So now let's cancel here. So that 2 will cancel that 2, that 7 will cancel that 7, that a will cancel that a, that b, that b, that 3, that 3, that 3, that 3, that 2, that 2. And I think that's all we can cancel. And so what's left over? Well, we have a negative, we have a b, and we have an a. So that means we get a negative b over a. Okay. Now, what about if we did the other way? Well, what we could do is we could start canceling there. And we can say, well, that 7 goes in here once. It goes in here twice. One of those a's cancels one of those a's. We have 1 left over. Now, 18 times 2 is 36. So one of those goes in here twice. And one of those b's cancels one of those b's. So we have 1 left over. And that 2 goes in here once. That 2 goes in here once. And so now we have a 1 times a negative 1. So that's just our negative. Then we have a b to the first, so b. And on the bottom, we have 1 times a to the first, which is just a. And so we just get the negative b over a. All right, so let's do this again. Let's do this one. So we have negative 16. So we're going to have let's say, a negative 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 4 is 16. So that will give us that. And we have 6y's. And then times, and now we have, let's maybe put that negative 2 in parentheses so we can kind of keep it in track. Then we have a negative 3 times, here we have a 7, and then we have all over, and 15 is 3 times 5. Now 13 is prime, so that's times 13, times 1, 2, 3, 4y's. Now what can we cancel? Well, we can cancel a y here, a y here, a y here, a y here. Then we have 2's and 3's and 7's. Oh, there's a 3 we can cancel. Now notice we have a negative times a negative. So let's go ahead and make those positive so we don't have to worry about them. Then we can cancel that 3 with that 3. And that's pretty much all we can do. And so now let's go back and circle. We have a 2, a 2, a 2, a 2. And then we have, where'd my mouse go? There it is, a y and a y and a 7, and then a 5 and a 13. All right, so this one we might have to work on. So we have 2 times 2 times 2 times 2. Well, we know that's 16. So we'll have 16 times, and what we have is 7. So we'll have to multiply that out because I can't do that in my head. So 6 times 7 is 42. 7 plus 4 is 11. So that looks like we have 1, 1, 2, and then we have 1, 2y's, so that's y squared, over. Now 5 times 13, well, again, let's go ahead and multiply that out. 5 times 3 is 15, carry 1, 5 plus 1, 6 over 65. And that then would be our final answer. Now, could we do it over here with cancellation? Sure, we could. All right, so let's see here. 3 will go in here 5 times. 3 will go in here 7 times. Our plus times a plus is, our negative times a negative is a plus. Now 4 of those cancel, 4 of those leaving 2. Now we have 16 times 7. Hey, that's 112. And then we have y squared, so it looks good. Down here we have 5 times 13, which we found was 65. So both ways work. You know, some people again are going to like the one where you show everything out here like this and then cancel easier. Others are going to like it this way. Doesn't matter how you want to do it, both ways you'll get the same answer. All right, so let's stop there.